Dear students, welcome in question number 49 of NSEP 2022, and this question has more than one answer, so we have to check all the answers of this question. And question is, a hydrogen atom is in ground state n equal to 1. The magnetic field produced by revolving electron at center of atom is B0. Atom is excited to state n equal to 4. According to Bohr model, the correct alternatives is R. Magnetic field at center of atom n equal to 4 becomes B4 equal to B0 upon 64. Energy absorbed by atom is going from n equal to 1 to n equal to 4 is this. Change in magnitude of angular momentum of electron is 3h upon 2 pi. And fourth option is, assume that this excited atom n equal to 4 is at rest and it makes transition to ground state n equal to 1 in a single quantum jump of an electron. And we have to try all the option. As in option 1 we have to calculate magnetic field, and in option 2 we have to determine energy absorption, and in option 3 we have to determine angular momentum, and in option 4 we have to determine the recoil speed of the atom. So let's start the solution. And we know that the energy of electron in nth state is, we know that En equal to minus 13.6 upon n square electron volt. And if we want to determine the energy absorbed from transition n equal to 1 to n equal to 4, it should be E n equal to 13.6 1 upon 1 square minus 1 upon 4 square. And if we solve it, 13.6, 16 minus 1 upon 16, and after solving it, it becomes 12.75 electron volt. This is the energy when during the transition of electron from 1 to 4. And if we check energy in option B, energy absorbed by atom is going from n equal to 1 to n equal to 4, that should be 12.74 electron volt. So one option B is the correct answer. As I have already mentioned that this question has more than one answer, so we will try the another option. So now I will calculate the angular momentum. So angular momentum, here answer B is correct, and angular momentum L equal to NH upon 2 pi. Hence change in angular momentum, momentum delta L equal to 4 into h upon 2 pi minus 1 into h upon 2 pi. As electron has transited from 1 to 4, so in one case n become 4 and in another case n become 1, and change in angular momentum is 4h upon 2 pi minus 1h upon 2 pi, so it becomes 3h upon 2 pi. So if we check the answer, and in option C, change in magnitude of angular momentum of electron is 3h upon 2 pi. This 3h upon 2 pi represents that option C is also correct answer. So maybe A or D are also correct answer. So we will solve again for the another options. So we know that atom will emit photon by the energy of in first option 12.75 electron volt. So when it makes transition to ground state by conservation of momentum, so momentum of recoil electron, it should be equal to momentum of photon, momentum of photon, and that should be equal to E upon C. Momentum should be E upon C. So mass of a atom into velocity, if we calculate it, then it should be 12.75 electron volt. So multiply by 1.6 into 10 to the power minus 19 upon, this is the energy, and divided by C. This energy is 12.75 into 1.6 10 to the power minus 19 and divided by this C. So 3 into 10 to the power 8. This is momentum of recoil electron, and this is E upon C. So here mh, we know that in question mh, this is mh is given 1.67 into 10 to the power minus 27 kilogram. So V equal to 12.75 into 1.6 into 10 to the power minus 19 upon 3 into 10 to the power 8 divided by this mh. So this mh is 1.67 into 10 to the power minus 27. So if we solve it, it becomes 4.1 meter per second. So if we check answer, if we check option D, and in this option V is 4.1 meter per second, recoil speed of the atom. So this option D is also the correct answer. So we have seen that B, C and D are the correct answer, but we have not checked the option number A yet. So now we solve for the answer for the option A. So in option A, we know that a magnetic field at center B is equal to mu naught I upon 2R, and B equal to mu naught, we can write E V upon 2 pi R upon R, or we can write it mu naught E V upon 2 pi R square. This is the magnetic field at the center, and B is equal to mu naught E upon 2 pi V naught upon N R naught N square whole square. We have put the value of R in this term and put the value of V in this term. So where V naught and R naught are the velocity and radius of the electron in ground state, and if we see that there is a n square to the power 2 means n to the power 4, and this is n, so this is n to the power 5. So B is inversely proportional to n to the power 5. B is inversely proportional to n to the power 5. So when for n equal to 4, B is B naught upon 4 to the power 5. If we take all the constants are B naught, so we can write B naught upon 4 to the power 5, or B naught upon 4 to the power 5 means 1024. We have taken V naught, E, V naught, 2 pi, R naught, B naught. We have represented by V naught, and we have taken 4. So B is equal to B naught upon R 4 to the power 5, 1024. And in answer A, it is given that B is equal to B4 is equal to B naught 64. So answer A is not the correct answer. So in this question, answer A is not correct, but B, C and D are the correct answer. So dear students, in another problem we will meet again with the problems something like that which have more than one correct answer, and these problems are very good problems. So thank you very much for watching this video, and write us if you feel any problem for preparing the NSEP examination. Thank you very much.